Today we're talking about structs. So structs is a shortcut for structures. So it's a collection of heterogeneous, that is, different types of objects. And we have seen in the past that we could have arrays of things of the same type. So for instance, we could have an array of integers, we could have an array of char, we could have an array of strings even. But a struct is a way for us to be able to make a collection of different types. So there are some sample programs in the space below, and I'll show you in a moment where you can find those. So structures can have a structure tag name as well as structure instances, and we'll see examples of this. You may have taken Java programming previous to this. If you have done so, you can think of a struct as a class, except for it doesn't have any methods associated with it. It's just a way to group the data. If you see this example right here, it gives you an all-in-one file, all of the sample programs that are below. And another way that you can find it is if you go to the website bit.ly/cs141, takes you to this bit.ly/cs141, takes you here to this page. On this page then you can go down to C++ notes. Within C++ notes, come down here to structs, and in structs, here's all these sample programs that we're going to be looking at right now. Let's take a look at these one at a time, building on the ideas to give us an understanding, appreciation of how we can use structs, what they're useful for. First idea is if we want to, for multiple employees, if we want to keep track of their name and we want to keep track of their wage. So running this program is going to be like what we see here, where we enter a bunch of names and wages for, looks like 5 employees, and then after that, then their information gets echoed. So obviously we need to store these multiple names, these multiple wages somewhere, and we do that with arrays. So here we have an array for names, and the array size is 5, so there's 5 employees. The name size is 15. So this would be an array of name, where there's 5 of them, index 0 through 4, and for each of these there are 15 characters to store their name. And then we also have wage, which is floating point for them, and this would be the same size for floating point number. And this again is 0 through 4, so the same index values for these, and this is for the wage. So if I want to refer to a particular employee, it's a cross-section of both of these. So for instance, this employee right here, I could use the name array to get the name part of it, and then I could use the wage array to get the wage part of this employee. But again, I'm using 2 different arrays to do this, and in other circumstances I might use multiple arrays, more than 2 arrays, to have parallel arrays. This is a little unwieldy. If we wanted to use a function to manipulate these, I would have to pass these multiple arrays to that function. So the structs gives us a solution to solving this problem that is helpful. In this particular case though, we can see how we would manipulate this. I have a for loop for my 5 elements, and for each one I say please enter the name and wage, and then for each one, in this case it's C++, so we're using cn, so we enter into the ith row for the name, and in that same row the ith row for the wage. So the first time through, the value of I is 0, so in the 0th row, whatever the user types in is going to go into this top row up here. So in the case of this sample output, this first one would be Alan, and the value would be 5. That's this that would be entered right here, and then Bert for 9, Castro for 5, Doris for 6, and Albert for 3, as so. Okay, and that is reading in this information in this section of code right here. After we've done that, then we want to echo the information using this array. So I print out the employee information is, and again then I have a for loop that goes through each of the 5 elements indexed from 0 to 4, and then I just print out the name in the ith row and the wage in the ith row. So again, this notion of parallel arrays where I have the same number of rows for both of them. So this is what we want to do, but we want to do it without having to have multiple arrays. We want to have another way to do it that's more convenient. And this is the motivation behind using a struct. So here we have an example of a struct employee, which is our alternative. And instead of having multiple arrays, so one array for each one of these, now in this case, I put them all together into a struct. So let's see what this would look like in memory if we drew a picture of this. For a single employee, we would have the first name, which is same size, which is 15, so that's 15. And then we'd have last name, which again is the same size of 15. And then we'd have the wage, which is a floating point, hourly wage, and then the gender here, which would be a single character. And so this is for a struct employee. So for the whole struct employee, I could think of that as being all of this. Okay. So there is an employee right there with all of those different pieces. So if we make a the other thing it's important to note, when you're declaring struct employee, we are making a new type. And the type declaration starts at the opening brace, ends at the closing brace, and we have to give it the semicolon right there at the end. That's an easy thing to forget. So for comparison purposes, if we had int is a type, and instead of int now we could use employee as a type. So here we have employee person, which is a declaration. So a person is a particular instance of this. So this just declares the structure. So just like when I have int x, here int is the type, down here employee is the type, and here x is the instance, and here person is the instance. So if I had int x, so I could have a box that's labeled x, and an int would go inside the box. And so now I have a box that's labeled person, and inside the box, though, I get more stuff, to use a technical term. So, oops, that didn't work so well. Never mind. So again, I'd have first, last, wage, and sex for person. So here's this person, which has that. So this one up here is declaring the structure. It doesn't really allocate memory for an instance of it. It just says such a thing exists, and here's the different pieces and the types that go into it. Down here we have in fact actually allocated memory when we did employee person. Once we have declared a person, then we can use that person. So just as for x, you could use x in a scanf. In the case here we're using C++, we could have a cin statement. And to access the different components inside of here, first, last, wage, sex, we use the dot notation. So person is the instance, because you could have multiple employees. I could have person 1, person 2. So for this instance, person, I want to access the first name part of it. So I use dot first for the first name part of it. Similarly for last, wage, and sex. So that's for the different pieces. So when we were running this program, if we ran it and actually typed in this information, Dale read 6M, what that would give us would be Dale read, my wage is $6 an hour, male, like that. And notice I didn't type in 6.0, it did that conversion automatically down here when if I gave an input as 6 and wage is double, then automatically the integer for 6 gets promoted to floating point for 6.0. And then we echo that information, and so we say person dot first, person dot last, person dot wage. These things all get printed out, and it accesses these different components here inside of the struct. Other thing that we can do is when we make an instance, so we had person up here, and now here we have second person, so it's a different one. So we have second person. And second person, I'm declaring second person and giving the default values as we go. So again, to draw the analogy to an integer, if I said int x equals 3, int is the type, here employee is the type, and here x is the instance, here second person is the instance, and here 3 is the initial value, and down here this whole thing is the initial value. A little more complicated, there's more pieces to it right now. So second person would have first, last, a wage, and sex, and then these pieces that are given here get entered in. So we'd have Fernando Lopez, it's important to say it with the right accent, $14 an hour, male. And there's that instance of a struct right there. Now that we've shown how we could use a single instance of a struct, we can show how we can group these things together. So in this case, we've simplified a little bit. Up here we had lots of different pieces inside the struct, first name, last name, wage, sex. And now down below here, we are going to simplify and just have a few pieces. We're going to have only name and wage to simplify the example a little bit. In the past, we've seen, for instance, an array of integer would be int, and I would have scores for a test, and then square bracket with some size of how many I'd want. For instance, I could have 7 different scores in there. And here again, we're doing the same thing, where here's the type, and then we have the instance names, scores, and here it's people, and then the size is this part. Same idea, except for now we're adding the notion of an array, so we're combining things together. When we get the input for this program, as before, we have the input section, and then we have the output section. So this reads the values in, and one at a time, these would be things that the user would type in from the keyboard, and then we go through and we echo all of those out. So let's draw a picture of what this would look like. So people is the name of it, and inside of this I have the name section, and I have, let's see, and I have the wage section. All right, so this is 15 characters, and this over here is a floating point number. It really probably should be double. And we have 5 rows, if you will, in the table, where each row has 2 pieces. So now my table has elements of 2 different types. It has an array of char, which is one part of it, and we have a floating point value, which is another part of it. So if we run this program and we take this input that the user types in, these values are going to go into this table down here. So as this is run, it would be Alan for the value 5, Bert, and remember implicitly there's null characters that get stored in here. Bert for 9, Castro for 5. Usually we just leave those nulls off, and it's understood that they're there. for 6, Albert for 3. So that's what's in our table, and that information gets read in right down here. Please enter name, wage for each employee, and here's where the name part gets read in. So we go to the array called people, and the name part of it, whatever the person types in right here, goes into the name part of it. So the first time around, when I is equal to 0, would be at the 0th row, and whatever they type in for the name would be entered right there, and whatever they type in second for the wage, that would be entered right there into people sub I, that is people sub 0 dot wage, which is this second half, the second part. And then we go through and we echo that information. As similarly, we go through a for loop going through all of the elements in the table, and we pull off for each element in the table. We print out the name part of it, we print out the wage part of it, and then that's it. So hopefully that is straightforward. I encourage you at this point, if it seems like it makes sense to you, think about this example, think about what it does. Make a little toy problem for yourself to try it out and see if you can write a small program to exercise your understanding of this. It makes sense to think of a collection of people, say a collection of students, as having name and other associated information. Typically address information is something that people have and businesses have. So here we see that we can make a struct for address, and the address has the city, state, and zip. Nothing particularly new here, but now here we see that for an employee, that an employee not only has last name, first name, but also has an instance of address. So now we have a struct inside of a struct. So let's see what this looks like. Here when we say, so employee is the type, and employee is the instance. So we're allocating memory for this, and each of those has all this stuff in it. So let's think about what that would look like. So we have an employee, and an employee has last name, which is an array of size 15, right? The name size is 15. And we have the first name. Again, it's an array of 15. And then we have one of these, and this is where it gets interesting, where we have the address. So there's the address. And the address itself, now I look up here, has a city, state, and zip code. Okay, so there is the address, all those pieces in it. And then we go back down here to employee, and we had finished, we just did this part right here, the address, but we had not yet finished doing this part down here for float wage, so we still got to do that. And so we have wage, which is a floating point. Alright, so here we're declaring an employee and showing what the memory model looks like for an employee. So once I've done all of these, then this is what I've got, an employee. So for an employee, again, using the dot notation, I can get at a particular individual field like that, and using double dot notation, I can go into the address dot city or dot state dot zip. And here we see how that would work. So here is our input into an employee. So please enter first, last, etc. And when I get to the address, and that's what I'm showing right here, the address dot city. So an employee takes me to the box, the dot takes me into the box, the address takes me to this part of the box, the dot right there takes me into the box, and then city is which part inside the box are we thinking about? And similarly for state and zip. So in the case of the above sample input, that is, let me see, where's our input here? Please enter the first and last. It looks like I didn't really provide that there. Oh no, I do. Here it is. There's the input that gets provided. So this would be Sanchez, Sunil, and then Chicago, Illinois, 60607, and the wage is 50,000. So good starting salary in computer science these days is averages about 63 or 64,000. So maybe this is not a computer science major. Okay. For the input, and similarly for the output, using a nested struct. Now we can think, if we in fact had a nested struct like this with a bunch of information, what could we do with it? We could make what essentially is like a database where we have lots of employee information, and we could use that information and go and do a search of employee information. And that's what this sample program does. So there's a few pieces in here. It allows us to type in information and then go and find an employee and then print it out. One issue with this is we have a function to search for an employee and then we print out that employee. But what if no employee is found and I go and try and print out a non-existent employee? So the function that does that search, I'll cheat and jump ahead a little bit here. The function that finds an employee right here, that function returns employee. But if no employee is found, I have to have something to return. So I need like a global placeholder for a employee which represents the no employee found employee, and that's what we have right here. So we make an employee and we call it null employee, and the first name is none, the last name is none, there's no street, there's no apartment number, there's no city, and so forth for all of these different components. There's no zip code, and for the wage is also 0. So default values. So set employee, well, let's start down actually in main, down below here. Alright, so here's main. So inside of main, I have the type is employee, and then I'm making an array called the employees. So I have the employees, and this is an array where each element of the array has a bunch of pieces in it, as we saw before. So an employee has first, last, address, and wage. Okay, so the employees has first, last, has address. I think that was capitalized. And wage. First name, last name. And address itself is broken up further. And let's see how big our table is. It's of array size, which is declared, I think, oh here, it's only 2. So that's not much. Okay. Toy problem, just small to illustrate the point. Address has all these different pieces, city, state, zip. What all does it have in it? Street, apartment, city, all this stuff, state, zip. So, right, so there's all these different pieces in here for address, city, street, apartment, right? And we would have to use dot notation. In fact, we should do this with a different color, because dot notation is going to take me inside the box here and then I have to think what is the other piece of information that I'm trying to get inside of each of these. Alright, and then we have a particular name, the key that we're searching for, the search name, and that's also an array. So somebody can type in a name, it's going to be stored in here, and that's what we use for searching. We start out by populating the array, and this is pretty small because there's lots of information for each one of these, so that's why the array is so small. So we call set employee, and we send it the employees at position I. So the employees is this entire array, and the employees at position I, the first time through I is 0, so the employees at position I, what we're passing it is we're passing it this. So when we catch it, we have to catch it as an employee. So let's go take a look at function set employee. So here's function set employee right here. So we catch this employee. Now we're using the C++ convention for a reference parameter. So just like if I pass an int and I want change to be reflected back, I would put an ampersand when I catch it in C++ to make it a reference parameter so the changes get reflected back. Here I put an ampersand so the changes to the employee are reflected back. So we prompt for the information, please enter first, last, etc. And we do get our input statement, and then we use the dot notation to read into the different components, address, state. So we're not putting everything in there, just first name, last name, state, and wage. Okay? So that information gets entered in from inside of this code right here for each of the employees. In this case, there's only 2 of them. So assume that we type that stuff in. Then we prompt enter the name for which to search, and the input gets stored into search name. So if we're searching, right, it could be Dale, that's what we're searching for. And then employee found, we're like, well, what is that? So we take a look up here, and we see that employee found is also of type employee. So we've got the employees, which is an array of type employee, and then we have a single employee found, which is of type employee also. So employee found is going to be some particular employee where it has in their address portion as well. So we call function find an employee. We send it the array of all the employees, and we send it the name for which we are searching. So let's go take a look at find an employee and see what that does. So find an employee. Here's find an employee right here. So first of all, note that this returns an employee, as we said before. So if we type in Dale, D-A-L-E, that's the employee that would come in here for search name. That would be in that array. And here's the array of all of the employees. So we start out saying that employee found index is -1, so that's going to be that value is significant if we are not able to find the name we're searching for instance, Dale. So then we check here in our loop and do our comparisons. So we go through all the elements in the array, and then we take the name for which we're searching. In this case, for the particular row that we're on in the array, we look at the first name. And remember that StructComp, what it does, it takes our 2 arguments and it compares them. It does this character by character subtraction. If they're exactly equal, then we end up StructComp equals 0 means that they're equal. So here this first row says, is the name I'm searching for equal to the first name in this current row? And the second one is last name. So if it matches on either first name or last name, then we keep track of the index of where this employee was found at row I. Once we finish with that loop, either we found it or we haven't. If we found it, that means the index is not -1, it's some other value here in the array. In this case, it'd have to be a 0 or a 1. And then I return the employees array at that row employee found index. So it's going to return either that or it's going to return that. Instead of just returning a single integer, it's a little bit more complex. However, if it is equal to -1, that means we never got a hit up here. We never found the name as we went through all the elements in the table. So if it is equal to -1, then we do this return null employee. So here we see if I'm returning one of these things, that memory's already been allocated. But if I want to return null employee, I have to make something to return, which is why we started out with this null employee here to begin with as a placeholder that we could use when we're returning values from this function. And then that is pretty much it. After we found the employee here, then we just display the employee and we send it the employee that's found. So employee found is of type employee. You can see that right there. We take a look at display an employee. That's fine. Here's display an employee. It catches an employee. It does not have to be a reference parameter because we're not changing it. What this does do is it checks to see if this is the null employee or not. So it looks for the first name and makes sure that first name is not equal to none. If the first name is not equal to none, then it's actually going to print this stuff out. So poor guy, if some parent actually names him N-O-N-E, then this would not work. But we assume that that would not be the case. Otherwise, if the first name is equal to none, then it's going to just say employee not found and gives us that message. And that is how this program works using structs. So I hope you can appreciate that in a situation like this, if instead of address and employee, if these were all parallel arrays, that's an awful lot of stuff and names to be keeping track of. It's much more convenient to package them up, encapsulate them, have a single name around the outside of it, such as employee, and just to be able to make array of employee, to pass an employee, to return an employee, to do all these different things to an employee. If we think back to our original example of a type, a declaration, so int x. Int is the type, x is the instance of it. So here we're making our own type. So here struct employee is the type, and sample employee is the instance. Notice we're declaring it and declaring an instance all at the same time. So that's possible to do. Oftentimes this part will be left off, and that would be done in a separate step, such as employee sample employee. But you will see this sort of notation that we have here sometimes. So it's important to be able to recognize that when you do see it. The other thing is, if you understand how pointers work, that they're addresses in memory, we can have a pointer not only to something like an int or a char, but we can have a pointer to an employee. So here's employee star and then p employee. So the p right there is a convention, just like we use capitalization and camel case, to help indicate that p employee is of type employee star and not just an employee. Again, it's helpful with the name of a variable to give as much information as possible, and that's what we're doing here. So again, we have an array of type employee, so an array of people, right? And these are type employee, and in this case there's 3 of them with just name and wage. So this is size 15 here. So this is the name part, this is the wage part. And when we type in the information, I have people at row I. Here we're using a sample employee first and reading into this sample employee. And then we see that we can do an assignment all at once of an entire struct at a time. So we have sample employee, which was declared up above here. and we use sample employee, which has a name of 15 characters wide and a wage, and we type in the information into sample employee, such as Dale 3. So Dale 3 is typed in there. And then when we get to this line down here, we assign the whole thing at once. So it stores this whole thing into here, giving us Dale 3 like that. So you don't have to do the pieces separately. You can assign all the fields at once, and that's very handy. We see that P employee is an employee star. It's a pointer to an employee, so we can use what we know about pointers to do this. So in this line, P employee equals ampersand people sub I. So P employee is an address in memory, and when I is equal to 0, then people sub 0 is the top row of the people array, and ampersand is the address of it. So essentially what that does is it makes P employee point to the address there in memory of where that is. Then when I want to use that pointer down below, I can dereference the pointer here by saying star P employee. So I dereference the pointer, which essentially takes me into the box. And then dot name tells me which part of it, the name part of it right there. The reason we need these parentheses, this could be a sample test question, by the way. Those parentheses are needed because dot has precedence over star. So if we didn't have those parentheses there, what it would try and do, it would try and do this. It would try and do P employee dot name. So it would go to P employee, try and take the dot name part of it, but that doesn't make sense because this is a pointer. It's not an actual employee. It's just a pointer to an employee. It's like an ID number is different than the person who the ID number belongs to, right? This is just like the ID number. So it tries to take the dot name part of it, and then it tries to dereference that. So this is just clearly not going to work. So we need to have those parentheses there. There's this notion of dereference and take member of, which is happening right here. So this is dereference and take member of happens all the time because we typically use pointers when we have structs. Is very common, and this is a pain to do, to remember to have the parentheses around this part of it, right? That's a pain, and because of that there's a shortcut notation called the arrow notation. So another way to do P employee dot name would be to do P employee arrow, so it's the minus sign, the greater than sign, name, like that, and that would be equivalent to what we have right here. We're getting there, almost done. So let's think about reference parameters and employees and passing them to a function. So here in main, so first you'll have your declarations for your structs up at the top of your program. You'll have your pound includes, maybe some global constants that are going to affect the sizes of things, and then you're going to have your struct declarations like we have here, employee, with name and wage. So inside of main, again, I have an array of people of some size, and what is array size in this particular case? It's 3. So here I have my people array. It's small, and I think I just had the name portion and the wage portion for each one of these. And for each row in the table here, I'm now calling a function, readIn, and I send it what row in the table I am, and then I take people sub I. That's going to be people when I is 0. It's going to give me this, and then I'm taking the address of this. So this is reference notation in C. We're pass with an ampersand, catch with an asterisk, and use with an asterisk. So here we're using it with an asterisk. So here we're also using it with an asterisk. Remember that the arrow notation is shorthand for all of this, for use with an asterisk and then take the member operation, right? So it's shorthand notation. So that's why both of these work, because the arrow is just shorthand for this, and when we do this, we are using the arrow, the asterisk, to dereference the employee. So both of these will work. Well, I hope you've enjoyed that. And again, let me emphasize that if you think you understand structs, you really should go and write a small program using structs. Otherwise, I would challenge the notion that structs are something that you understand. Good luck.